So we've seen how we differentiate polynomials, but of course polynomials only have powers that are positive integers. What about ones like this where the power is not a positive integer? So let's go back to first principles. Let's see what happens. So function x is 1 on x. Function x plus h would be 1 on x plus h. Plug it into the first principles formula. Fractions on fractions, don't like that. So let's tidy that up. We'll push the x plus h down to the denominator, which means the top becomes x minus h. Play with that a bit more. We've now got the situation where h will cancel with the h, but we can now substitute 0 in, and we end up with minus 1 on x squared. But think about this. If I did put it in index form, x to the negative 1, and if I did use the rule that we'd already seen, so I would have brought the negative 1 to the front, subtracted 1 from the power, I would have got negative 2, which is minus 1 on x squared. So actually, the rule does work for negative numbers as well. So even though that was the rule we discovered for polynomials, it'll work for negative powers. I guess the other one we really need to look at are fractional powers. Will it work for that as well? So let's investigate the square root of x. Function x is the square root of x. Function x plus h, square root of x plus h. Put that into our first principles formula. Now how am I going to tidy this one up? Well, I'm going to do something similar to what we used to do with surds. But instead of rationalising the denominator, I'm going to rationalise the numerator. So I'll multiply everything by the square root of x plus h plus root x. On the top we get difference of two squares, so it becomes x plus h minus x, and on the bottom we have h times those surds. But on the top now, I get h, which will cancel with the h in the denominator, and I have something I can substitute into. Sub 0 into that, and we get 1 on root x plus root x, 1 on 2 root x. Okay, what would have happened if we'd used the rule that we'd already discovered? So function x is x to the power of a half. I would have brought the half out the front, subtracted 1 from the power, so half minus 1 is minus a half. Well, a half x to the minus a half is 1 on 2 root x, same answer. So it works for fractional powers as well. So that's great. Our one rule, yes, for polynomials, but we can do it with anything. X to the power of something, it's going to work for us. So now if I get something like this, 3x not a problem, but before I do the 1 on x squared, let's change it into index form, and I can use our rule that we know. So 3x will become 3, x to the minus 2, well minus 2 comes out the front, it'll become minus 3. I like to give my answer the way the question's written. They didn't use negative indices in the question, so I'm not going to use it in my answer. So 3 minus 2 over x cubed would be my answer. Let's do one with surds. So we have x squared root x, but that I can rewrite as x to the power of 5 on 2. Now I'll use my rule. 5 on 2 comes out the front, subtract 1 from the power, 3 on 2. But x to the 3 on 2, again, I'll match the way the question's written. It was in surd form. Well, x to the power of 3 on 2 would be x root x. Oh, we've already got 3 written there. Now, this one here, let's put it into index form. Lucky we got the chain rule from yesterday, because how do you expand out 5x plus 4 to the power of negative 2? That's a little bit tricky. But I can use anarchy. Bring down the power. So bring down the power, we get negative 4. Lower the power, becomes negative 3. We're going to push that derivative out, so diff the inside. That's 5. 5 fours are 20. Again, I will match the question, so I won't leave it as negative 3. I'll write it as minus 20 on 5x plus 4 cubed. Square root of x squared minus 3. I can now differentiate, because I can write that as x squared minus 3 to the power of a half. Again, not something I could expand out if I wanted to, but I can still differentiate now. Bring down the power, a half. Lower the power, becomes minus a half. Push that derivative out. Diff the inside. That's 2x. Half times 2x is x. So there's the answer, x squared minus 3 to the power of negative half. I'm going to take it out of that form, and it would be x on the square root of x squared minus 3. Okay, that'll do us. So just playing with powers that aren't positive numbers.